So when we look at the squeeze theorem is known by a couple of other names, the sandwich theorem, the pinching theorem. What it deals with is deals with functions whose limits we can't easily compute. To put it in perspective of something that's a little more real world, think of yourself as the defenseman on a hockey team. The forward has just gotten the pass near the blue line close to the boards, and what your job as the defense is to squeeze that forward into the boards. So in that case, the boards act as one of the functions, you act as the other function, and we're trying to find the location of the forward. We've actually got 6 different formulas that we're going to use talking about the squeeze theorem. Specifically, we're going to look at these in terms of trig functions with limits. So as we can see, we have some sines, some cosines. We have k as well involved with some of these limits. K is just some constant, so it's going to be a number. And what our goal is to convert a given limit into something that looks like this. We can then cancel off pieces that have this limit in it and deal with the rest of the math as it is. So why do we need to deal with the squeeze theorem and have these limit definitions? Well, because if we look at any of these, like if we take number 1 for example, we get an indeterminate. So sine of 0 divided by 0, well, sine of 0 is 0, 0 divided by 0 is indeterminate. Dealing with other indeterminate limits, we've actually dealt with things such as factoring, foiling, rationalizing. None of that's actually appropriate with the squeeze theorem because of the trig functions that we're dealing with.